Digital modulation techniques is the topic of this lecture. Before this lecture, we have talked about different modulation methods, different modulation techniques. Especially, we have discussed analog modulation methods, which include amplitude modulation, frequency modulation, and phase modulation, which are the three main modulation methods used in analog communication system. In all the modulation methods, one thing is common, that one of the characteristics of the carrier signal changes in accordance with instantaneous value of modulating signal. So when amplitude of or instantaneous value of message signal changes, accordingly, one of the characteristics of carrier signal changes, and accordingly we call them as amplitude modulation, frequency modulation, and phase modulation, respectively, for change in amplitude, frequency, and phase of the carrier. Whatever is the change is always proportional to instantaneous value of modulating signal. That is very important. Whatever is the change, that is always proportional to instantaneous value of modulating signal. So in this method, in this topic, we will discuss about digital modulation techniques. Digital modulation techniques in which the techniques are similar to analog modulation methods, which are amplitude modulation, frequency modulation, and phase modulation. Similarly, those changes will happen in carrier signal, but there is one major difference between analog techniques and digital techniques. That major change is, in the digital modulation methods, the signal will be digital. What do we mean by digital? Digital means the signal will be a stream of bits, which means there will be pulses, high pulses, low pulses, higher and lower pulses, representing ones and zeros. And there are different digital patterns. There are different data patterns, return to zero, non-return to zero, NRZ, and return to zero formats. So there will be different formats, but whatever is the I'm sorry, data format, accordingly, when ones and zeros change, accordingly, there will be change in one of the attributes of the carrier, as we have seen in the amplitude, frequency, and phase modulation. So let's start the digital modulation techniques discussion. Is one type of process used to change the characteristics or properties of carrier signal with a modulating signal. As I told you, this is very common in all the modulation method, that one of the properties or one of the characteristics of carrier signal, we know carrier is a high frequency signal which is required in order to make the transmission of message possible. So the digital modulation involves, as I told you, amplitude modulation, frequency modulation, or phase modulation. Accordingly, amplitude, frequency, or phase of the carrier will change. The information is transmitted, as I have told you, in the form of bits, unlike analog modulation method where the information is in the form of analog or continuous signal, whereas in digital, the signal is in the form of stream of bits. Same types of modulators and demodulators are used to transmit analog pattern as we use digital data as we use in the analog data transmission. So one interesting diagram can be seen here. Look at here. There is a binary pattern. This is the data which we want to modulate. This is the data which we want to transmit. 0, 1, 1, 0, 1, right? So this is a stream of bits. So rather than the signal present in the form of analog, the signal is present in the form of digital. Okay, and its corresponding pulse representation can be seen here. You can see 0, 1, 1, 0, and 1. 0 1 1 0 1, right? 0 1 1 0 1. So this is a representation, all right, which is representing this stream of bits which we want to modulate. And this is a carrier frequency. We know that the carrier signal is always a high frequency signal. So what will happen when this digital signal is modulated? See, message signal is always modulated. So what is message signal here? Digital signal. Now there are three major types of digital modulation, three broad categories of digital modulation methods. They are ASK, FSK, and PSK. ASK stands for amplitude shift keying. FSK stands for frequency shift keying, whereas PSK stands for phase shift keying. That is ASK, FSK, and PSK. And I will tell you, these three modulation methods are, they correspond AM, FM, and PM. How you can understand? Look at the first one. You see the carrier signal. Look at your carrier. The carrier signal is same. Frequency and phase both are not changing in the first one. But you can see here the amplitude is changing. How? When the bit value, when bit value is 0, so when it is low level means the amplitude is decreasing. You can see here. The amplitude is decreasing, and when it is becoming high, you can see the amplitude of carrier signal is increasing. So amplitude of carrier signal is high, low, high, low. Whenever the beat patterns or beat values are high, the amplitudes are high. Whenever the beat values are low, the amplitude become low, and so on. So this can be continued for the the continued expression of or waveform of the carrier signal. So what we can observe in ASK is you can say that it's similar to amplitude modulation, but not analog. It's a digital, because the data here, message here is digital signal. Carrier, of course, is analog signal. Okay, and the characteristic, which is amplitude here, the amplitude of this carrier signal is changing in accordance with instantaneous value of the message signal, which is given here as digital signal. Now you can see FSK, which is frequency shift keying. FSK. Now what is happening? You can see here, when the bit is low, you see that frequency is almost not changing. When the bit is high, you look at here, so it's higher bit means ones. So you can see that whatever is the carrier frequency, if you compare the second cycle here, this corresponding second cycle, look at here. There are two cycles coming. Two cycles means the frequency has increased. Again, you look at the third cycle of the original carrier wave. Here there is one cycle. See here, there are two cycles. What does it mean? It means whenever the bit is 1, the frequency is increasing. Whenever bit again becomes low, that is 0, you can see here frequency remains same. And again, when it becomes 1, you can see that the frequency has increased. Is it not interesting? It is very interesting. If we have understood the concept of frequency modulation, I think this is the same way FSK is working. The frequency of the carrier signal is changing in accordance with these values. What these values? The values are of discrete signal, digital data. When it is 1, frequency is increasing. When it is 0, there is no change in frequency. Is that clear? So that is the method called as FSK. There are a number of variants. We are initially talking about broad categories of FSK, ASK, and PSK. ASK is further divided into 2-3 types. FSK is again divided into a number of types. We are talking about broad categories. So you can see the next one is PSK. Now what is important here? Look at PSK, the original carrier signal, initially in the first cycle, there is no change in either amplitude phase. and frequency. But if you see the second cycle, look at here, frequency is not changing. But what is changing? You can see here, it's not starting from this particular point. Look at here, when it is ending, rather there is a phase delay up. There is a phase delay up rather than starting from here. There is a phase delay of 180 degree. There is a phase delay of 180 degree, right? Rather than starting from here, it's 180 degree actually, right? It takes here a 90 degree, then it reaches 90 degrees. So of course the phase delay is 180 degree pi radian. So you can see in the second cycle, frequency and amplitude is not changing. There is only one cycle, but the phase has changed. Similarly, look at the third cycle. Again, the phase has changed. And look at the fourth cycle. It remains same because it has low value. Again, it becomes high. That is, the digital input becomes high. The phase, original phase of the carrier has inverted. Inverted means the Bell structure is inverted means what? Inversion means 180 degree phase delay. 180 degree phase difference, phase shift. So that is there. Interestingly, this method is similar to phase modulation. In phase modulation, phase of the carrier changes in accordance with instantaneous value of modulating signal. So sometimes it's very interesting to understand these digital modulation techniques, which are what I can say, similar to analog modulation methods, which if we understand analog modulation methods in principle, there is no difference. There is no very, much complexity involved in understanding how digital modulation techniques work. What is the major change that occurs in digital modulation method is the data, the message signal, which is now the digital signal. And that digital signal, again, we know is in the form of ones and zeros. Ones represent high, outputs in digital, and zeros represent low. So low and high will accordingly affect amplitude, frequency, and phase will become higher and lower in terms of amplitude, frequency, and phase, respectively for ASK, FSK, and PSK. It's so interesting. So this particular slide gives you an entire picture, an entire scenario of different digital modulation techniques. The digital modulation techniques are of mainly three types: ASK, FSK, and PSK, in which amplitude, frequency, and phase respectively vary in accordance with instantaneous value of the digital signal. Digital signal here is the message signal. All right. Now, the modulation the modulation uses discrete signals for modulating a carrier. All right. You can see here, this is a carrier and this is a discrete signal. When the discrete signal is high, high frequency carrier is present. When there is low, the amplitude almost becomes null because there is low amplitude. There may be some low amplitude as well, but that will not be counted as the significant amplitude. Again, when the beat is 1, there is the normal carrier signal, and digital modulation removes communication noise as well as provides enhanced signal strength. If we compare digital modulation method in comparison with analog modulation method, there are different advantages involved, but the major advantages are the digital modulation method has more noise immunity. The noise immunity is enhanced, means it doesn't get affected much by the noise signals in digital. Of course, there will be bit error probability due to different sources of error. We will discuss in subsequent lectures, but noise doesn't affect much in digital modulation. And the signal strength is enhanced, the quality is better in case of digital communication system. So therefore, when you see this digital video, digital picture, digital speech, in comparison with the conventional, earlier the analog versions of speech and video, digital TV, digital recording, you can experience the quality of picture, the quality of audio, the quality of video. It's just because of enhanced signal strength, lesser noise, better noise immunity, lesser effect of noise. So there are many advantages. It also gives more capacity of data, high information security, and accessibility of faster system. These are some more added advantages. You know, in analog communication system, you have limited capacity of data which you can transmit. But digital, especially after emergence of digital communication, after emergence of digital signal processing and communication, you must have realized, experienced that huge amount of data. You know, these days data is transmitted in Gbps, TBPS, terabits per second, gigabits per second. How it's possible? It's just because of this advent of digital communication system that allows huge amount of data capacity, huge, enormous data capacity, enormous channel bandwidth, and this is why large amount of data can be communicated. The next point is high information security. Noise immunity is good, signal strength is better, increased channel capacity and data capacity is there, data carrying capacity is there. But what is more interesting is security, intelligibility of message. The security of information which is communicated is much better in comparison with analog modulation method or analog communication system. The last point which is noted here is accessibility of a faster system. The faster communication, the faster access of data while receiving, while retrieving or while extracting any point of the system. The faster communication, faster access of data, faster receiving of data is also an interesting feature in digital communication system. This offers more capacity, more data security, good communication quality, faster system accessibility. Better capacity for conveying huge amount of data than analog. Data modulation techniques are in great demand. For main reason is the large capacity to convey the huge amount of data. There are three broad methods, broad categories of methods called as ASK, FSK, and PSK. So let's discuss one by one briefly in this lecture, and in the subsequent lectures. This lecture is introducing digital modulation techniques. In the next lecture, we will discuss all these modulation methods one by one in detail. All right. So ASK. Now look at here. Again, there is a binary sequence given. This binary sequence is nothing but digital data, stream of bits. If you can see 0011, 001, 001111, 010. So what you can see, whenever the bit is low, whenever the bit in the binary sequence or the stream of bits is low, there is no change in amplitude. But whenever it becomes 1, there is an amplitude, and that too, the amplitude is high level, low level amplitude, high level amplitude, low level amplitude, high level amplitude, low level amplitude, high level amplitude. So amplitude only changes. There is high amplitude, there is low amplitude. Very high amplitude, very low amplitude. In analog modulation, you must have seen the amplitude slowly increases, then slowly decreases. No. In digital, we have only two levels in the message signal, high level of amplitude, low level of amplitude. So when there is high level of amplitude will be there in the carrier signal. When there is low level of carrier amplitude will be there. So when we receive the signal at the receiver, whenever we get high amplitude, after recovering the signal, whenever we get high amplitude, there the receiver understands ones are present. And whenever it doesn't receive any amplitude, it understands there is a presence of zeros. So zeros and ones are interpreted at the output by detecting higher and lower amplitude respectively. So amplitude of resultant output depends on input data. When it is 0, the level of variation may be positive or negative. ASK is a type of amplitude modulation. ASK is a type of amplitude modulation that I have already told you, right? Why? Because in amplitude modulation, amplitude of carrier signal changes. Here also, amplitude of carrier signal is changing. The only bigger difference is the amplitude has only two levels because message also here has two levels. Unlike analog communication, where the message signal is a continuous signal which has a number of levels, not levels, it's continuous. So similarly, the change in amplitude of carrier is also continuous, whereas in ASK it has only two levels. You can see here, this level high and another level is low. So any modulated signal has a high frequency carrier. The binary signal when ASK is modulated gives a zero value for low input and gives a carrier output for high output. So we can also understand like this. The carrier amplitude remains there when the amplitude is high. It becomes zero when the amplitude becomes zero. Amplitude means amplitude of your message signal becomes zero. That time the ASK modulated signal, the carrier amplitude also becomes 0 and 1 respectively for 0 and high output of the high level of the message signal. Next category is FSK, called as frequency shift keying. As its name suggests, frequency will change, frequency will be drifting, frequency will vary. Is it happening? Yes. Look at here. The same stream of bits using same carrier. Now what is important here? If the bit is 1, it means higher bit, there is high frequency reported. When the bit becomes low, you can see separation has increased. It means the frequency has increased. Again, it becomes high. You can see high frequency separation is less. Whenever it becomes low, the frequency has become less. The interval has become, widened. The separation is wide. And the next you can see here 111. When the bits are continuously 111, you see there is a high frequency, and again there is F2. What is interesting here is, very interesting here is, we have in this method, see what happens. It is similar to frequency modulation. Here it's similar to frequency modulation in analog communication system. But in frequency modulation, in analog communication system, message is continuous. Change in frequency is continuous, which follows the change in the instantaneous value of modulating signal. Here we have only two levels in message signal, and accordingly we have only two frequencies. See here, low frequency F1, high frequency F2, and this will go on. So the carrier signal will have only two frequencies throughout the cycle. Low frequency when the message signal is low amplitude, high frequency when the message signal amplitude is high. So this is how FSK is generated, FSK works, and this is why this is the method is called as, or the method is similar to, is seen as similar to frequency modulation, because the frequency of carrier is changing strictly in accordance with instantaneous value of the message signal. The next one is PSK. P means phase. So phase will change. Phase shift keying means phase will change in accordance with, again, instantaneous value of message signal. So the phase of output signal gets deviated, changed depending on the input, and it has two types. There is a small typo mistakes, so let's correct it. It's not to, it's to, right? So better to correct. Okay, so let me again choose the pointer. Okay, so it has two types, BPSK and QPSK. That is, B stands for binary, Q stands for quadrature. Binary means 2, quadrature means 4. So we will understand. In binary, there will be 2 levels of change. In QPSK, there will be 4 levels of change. 4 levels of change means 4 levels of change in phase value. All right. So the phase of carrier signal is changed. The phase of carrier signal changes in accordance with the input. So sometimes we call it as varying the sine and cosine input of particular signal. Sine and cosine means, the sine and cosine correspond to the different, what I can say, beat patterns of the digital data, the message signal. Used for wireless LAN, where it is used for wireless LAN, local area network, biometric application, RFID application, Bluetooth communication. This is very, popularly used in these applications. As I told you that there are two main, versions. So one is BPSK. This is also called as two-phase PSK. Sometimes it's therefore also referred as phase reversal because there is change of phase from 180 degree. 180 degree, there is a reversal. So the sine wave carrier takes into phase reversal such as 0 degree and 180 degree. You can see in the diagram. And BPSK is basically DSPSC on a double sideband suppressed carrier modulation scheme. So sometimes it is compared as DSPSC. When we compare it, it is called as DSPSC. Why? Because in DSPSC, we know that there are two components, right? That is double sideband. So it's similar to that. You look at here. This is when it is one, you see that there is change in phase. Whenever there is change in amplitude, there is change in phase. Again, whenever there is a change, there is change in phase, and that to 180 degree. Whenever there is again change, so whenever the amplitude is changing from high to low or low to high, wherever there the phase is changing by 180 degree. This is what is called as binary phase shift keying. In the quadrature phase shift keying, there will be, four different possible phase values, and those values are 0 degree, 90 degree, 180 degree, and 270 degree. Because the entire, what I can say, cycle 360 degrees divided into four parts. In the BPSK, it is divided into two parts. So 360 degree divided by 2 is 180 degree each. Now there are four components here. Quadrature, therefore the name is quadrature. So divided by 4, so 0, 90 degree, 180 degree, and 270 degree. All right, so there are four components. Look at, this is a carrier signal. When this is 0, I mean, when from 0, 0 to 1, 0, so here you can see there is a change. Now you can see the next change, it at 90 degree, the next change is at 270 degree, means 180 degree, and the next change will be 270 degree, 90, 180, 270, right? There is no change, then 90 degree change, 180 degree change, and then 270 degree. So every after 90 degree, what I can say is 0, then 90, then 180, then 270. And therefore the bits are also changing accordingly. Look at here, 0, 0, 1, 0. In BPSK, what did we understand? When we go from 0 to 1, there is a phase change. Here also 0, 0 to 1, 0. So only one bit is changing, so phase has changed. Now 1, 0 to 0, 1. Both the values have changed, you see here. So therefore the change is more than these two bits are changing here. One bit is only changing, so the bit is changing accordingly. So it's a quadrature, and the four components correspondingly are 0, 0, 1, 0, 0, 1, and 1, 1. All right. So in other words, also we can say that in QPSK, we allow, two bits together to communicate. Rather than communicating single bit, two bits are communicated simultaneously. Two bits are used for coding. Two bits are used for, modulating the carrier signal together in QPSK. QPSK is the variation of BPSK like DSPSC, say a double sideband suppressed carrier, which sends two bits of digital information at a time. As I told you, sometimes two bits at a time is called as B digits. Digits mean binary digits. In abbreviation, we call it as digits. This converts into bit pairs and decreases the data bit rate to half, which allows space for other use. Data bit rate, it means the bit rate which is there in BPSK, and here more number of bits is there. So, we can effectively say the bit rate is improved, and the space which is, saved because of two bits are communicated simultaneously, that space can be utilized for other users. So that is the advantage in QPSK. There is another category called as DPSK, right? This DPSK is called as differential phase shift keying. Phase of modulated signal is shifted relative to the previous signal element. The signal phase follows the high or low state of the previous element. When we discuss in detail about DPSK, we'll understand this is a separate digital modulation method. When the data bit is low, the phase of the signal is not reversed. It does not change. Whenever it becomes high, you can see here, it changes, and again from 1 to 0 it changes. So whenever 1 comes, there will be change. Whenever 1 comes, there will be change, and depending on what is the data format we use, here the data format is not returned to 0 and that to inverted, so accordingly there will be output. There is one more category which is called as MRE, or MRE digital modulation method. MRE means, see, in DPSK you say that there is 1 bit. In QPSK we say there are 2 bits. So 2 bits means when you calculate 2 to the power 2, so there are 4. So 4 arrays are there, 4 combinations are there based on how many bits? 2 to the power 2. And in BPSK there were there are only 2 arrays, 2 components, 2 to the power 1, because bit is only 1. So when you increase the number of bits, suppose we increase the number of bits to 3, there will be 8 components. 8 components. So 8 arrays, 4 arrays. So similarly, there is a name for increased number of bits, MRE, MRE PSK, right? MRE ASK, MRE FSK, MRE PSK. 2 or more number of bits are transmitted at once on a single channel or a single signal, then it reduces the, of course, you have seen in the QPSK as compared to BPSK, there is a saving of bandwidth. And similarly, we can have bandwidth saving in the MRE methods of digital modulation as compared to their conventional counterpart. So this is a comparison of all the modulation methods which we have discussed, right? And before we discuss this comparison, let's sum up what we have discussed today in this lecture. We have covered digital modulation method in this lecture. Digital modulation method is a method of modulating the signal, modulating the message signal which is present in digital form in the form of stream of bits. So in analog modulation, there are popular methods called as amplitude, frequency, and phase modulation. Similarly, there are 3 broad categories called as ASK, FSK, and PSK, in which there will be definitely change of amplitude, frequency, and phase in the carrier signal, and that amplitude, frequency, and phase change in the carrier will be depending on instantaneous value of modulating signal. But the major difference between analog modulation and the digital modulation is, in analog modulation, the instantaneous value of the modulating signal changes in continuous manner. So the change in amplitude, frequency, and phase is also continuous. But in the digital modulation, we know that the message is the digital data which has only 2 levels, ones and zeros, and accordingly the change in either frequency, phase, or amplitude will have only 2 levels: high amplitude, low amplitude in ASK, high frequency, low frequency in ASK. High phase and low phase means no phase change and phase change in the PSK. So that is a summary of what we have discussed today about digital modulation method, especially the 3 categories called as ASK, FSK, and PSK. So let's have a comparison of these 3 modulation methods. This ASK, FSK, and PSK, we can always add B in front of the names. B stands for binary. So binary means when there is 1 bit in the digital value, so there will be 2 levels, 1 and 0. So there is only 1 bit. But if there are pairs of bits, so there will be 4 levels. So the name will be different. Q will come in front of the name. But ordinarily, by default, B will be there. We can say BASK. ASK is BASK. BFSK is FSK. BPSK is your PSK. So if we compare these three basic modulation methods, we'll find that BASK, there are 2 points, 0 and 1, symbol is 0 and 1, and in BFSK also. In BPSK, there are 2 points accordingly, as per the change in phase. BPSK, you have seen there are 2 phase values, and the information capacity is less in BASK, better than BASK is in BFSK, and 2 times of BFSK the capacity is there in the BPSK. And bandwidth is not very, saving is not there in BASK. Bandwidth is again not efficient in FSK, whereas in PSK, it's used for high speed data. We can save some bandwidth. QPSK, the number of points, the number of symbols are 4. You have seen there are 4 symbols. And in information capacity is twice of BFSK, and the bandwidth is high. We have seen the bandwidth saving is there because some half space is left, so bandwidth utilization efficiency is better. Embre, there is minimum shift keying which we'll study further, and the bandwidth is lower. Then there is a quadrature amplitude modulation we will discuss next. Then we will have a comparison 16 level QAM, 64 level QAM, then GMSK, their comparison in terms of bandwidth, information capacity. You can see that the information capacity is increasing more and more when we are going to higher levels. So that is there, which we can see. So this is how we can conclude that the digital modulation methods are very important in communicating the digital data, the digital message, in the digital communication used in a number of digital communication methods where we have also seen some examples in case of BPSK. And the major advantages which are associated with digital communication because of by virtue of using this digital modulation methods, those advantages include enhanced capacity, huge amount of capacity, large bandwidth utilization, effective bandwidth utilization, high bit rate, then improved noise immunity, improved signal quality are the major advantages that we have in the digital modulation methods. So that's all for this lecture today. Thank you.